Okay, today we're going to talk and I'm going to show you just a couple things, just a couple tricks for how to translate words, phrases, and sentences to expressions in math. One of the most intimidating things about math can be the word problems. Word problems can be tricky for two reasons. One, because they almost always give you more information than you need, and there's some thing in the question or the answer options that's designed to give you an opportunity to slip up. When we work on algebraic expressions and variables without that word problem thing, when we work on expressions rather than equations, we're not solving. So that opportunity to slip you up isn't there. But we still have to deal with how do we make words and phrases and sentences into numbers? How do we make them into algebraic expressions and equations? So that's what we're going to focus a little bit on today. This first thing here that you see is a picture right from the textbook. Most of these are self-explanatory if we think about them outside of a math context. We might not always think of more than a number as addition, but if I ask you, what is 4 more than 1, you're going to say 5 without even thinking about it. You just did addition. You just translated that word, those words, that sentence question into a math question. So if we look here, we see 4 more than a number. So if you see a phrase like more than, so I can highlight here. If you see a phrase like more than, you want to be adding. If you see less than, you are subtracting. If you see 3 times a number, well, you're going to multiply. And remember, we don't use the x for multiplication. We don't use the multiplication sign. We can just put the number and the variable next to each other. So a number, it's any number. We're using a variable to stand in for that number. Usually we're going to use the letter x as our variable, unless it tells us otherwise. We'll see an example of that soon. So 3 times a number is 3x. A number times itself, well, we could say x times x, but that's what squaring is. So we're going to say x squared, x with that 2 raised right above it. Product is a word that means or refers to the answer you get when you multiply. So if I say the product of 8 and a number, that's the same as saying 8 times a number. So I could have said, instead of 3 times a number, I could have said the product of 3 and a number. It's the same thing. Now, of course, we can add these together. We can combine different parts together. If I say the product of 6 and x, we stop there. You always want to read these left to right. Kind of don't look at the whole thing as one big problem. You want to break it up into its individual parts. So look at the product of 6 and x, stop. That's 6 times x gives us 6x. And then that product added to the difference, so stop. We're going to add, so we put plus. To the difference, now difference is the answer to a subtraction problem. So the difference between 5 and 4 is 1. In the same way that sum, S-U-M, is the answer to an addition problem. The sum of 4 and 2 is 6. So here we have the product of 6 and x, which was 6x, added to, or plus, the difference between 5 and x. The difference between 5 and x. Whenever you have the difference between, you want to subtract in the order that it presents from left to right. So 5 minus x. We put parentheses around it to show that we're doing the difference first. Quotient is just a fancy word for the answer you get when you divide. And you treat it the same way you did sum and difference. You go left to right. First is left, second is right. So the quotient of 6 and x is 6 divided by x. If I said the quotient of x and 6, that then would be x divided by 6. And then if you say 1/3 of a number, you are essentially multiplying that number, that variable, by 1/3, or by 1/2. So So if I say 1/2 of a number increased by 3, that would be 1/2 x plus 3. Now if I said 1/2 of 6 plus a number, well, we could do 1/2 times 6 plus x, but then we could simplify that to just say 3 plus x. So here are a couple of examples of that. Okay. So what you want to do is you want to read and transcribe from left to right, and you want to watch for the word than, because that's going to tell us certain things we need to pay attention to. So this first example here. A carpet layer charges $30 per hour and spends $12 a day on gasoline. Write an algebraic expression to represent his net earnings for one day. Now we're not actually going to solve this, because we can't, because we don't know how many hours he works. But that's what we don't know, how many hours he works, so that's our variable. So our variable here, x, is going to be